Hello dear students, I am Bhima Shankar Kotigi from Guru Basava High School Chavdiya. In this session I am going to discuss with you polynomial chapters for SSLC students. Right? The word polynomials already familiar with you because you are learned in the 9th class standards. 9th class. Right? The polynomials. Right? The word itself says that polynomials means poly plus nomials. Right? Poly plus nomials. Poly means many. Nomials means terms. Means polynomials is nothing but many terms. Polynomials is nothing but many terms. Or a polynomial is an algebraic expression consisting of multiple terms. Right? Consisting of multiple terms. Or another way, an algebraic expression in the form of p of x equal to xn x raised to n plus a of n minus 1 x raised to n minus 1 plus a of n minus 2 x raised to n minus 2 plus up to so on a x raised to 1 or a1 x raised to 1 plus a naught x raised to 0, or p of x equal to a n x raised to n, a of n minus 1 x raised to n minus 1 up to so on a2 x square, a1 x means x raised to 1 is nothing but x plus a naught x raised to 0 equal to 1. Therefore a naught into 1 equal to a naught. Right? Next here an, a of n minus 1, n minus 2, a2, a1, a naught, all are real numbers. Right? All are real numbers, and here x is a variable. Right? In this polynomial, x is a variable of the polynomial. For example, 5x cube minus 2x square minus 6 plus 2, and another example 2x square minus 7x minus 11. All are polynomials. Or x cube minus 7 plus 9. Right? All are polynomials. And in this polynomial, here 5x cube, right, 2x square, x and 2, all are terms of the polynomial. Right? All are terms of the polynomial. So in this polynomial, the terms of 2x square, 7x and 11. Right? The terms of polynomials. Next, the real number, right? And the real number that presides the variable is called coefficients of variable. Right? The real number that presides the variable is called coefficient of a variable. Right? Here the polynomial 2x square minus 7x minus 11. Here coefficient of x square is 2 and coefficient of x is minus 7. Therefore 2 and minus 7 are coefficient of x square and x. The x square coefficient is 2 and x coefficient is minus 7. Next, very important concept, degree of the polynomial. Right? Degree of the polynomial. The degree of polynomial means the highest power of the variable in the given polynomial. Right? The degree of polynomial is nothing but the highest power of the variable in the given polynomial is called degree of the polynomial. See the definition, the highest power of variable in a polynomial is called degree of the polynomial. So in this polynomial, the variable is x, right? The highest power, here x raised to nothing means 1, here x square. The highest power is 2. Therefore this is the degree of the polynomial. Therefore degree is 2. And another example, 5x cube minus 2x square minus 6 plus 2. Here degree is 3 because the variable highest power is 3. The next concept, the based on degree of polynomial, there are some standard polynomials like a linear, quadratic and cubic. So let us discuss one by one. So first one is linear polynomial. The first one is linear polynomial. A polynomial of a degree 1 is called, right? A polynomial of a degree 1 is called, that is a linear polynomial. Means degree of polynomial is 1. Such polynomial is called linear polynomial. Right? General form of linear polynomial is ax plus b. This is the general form of linear polynomial is ax plus b, where a and b are real numbers. Here a and b are real numbers and a is not equal to 0. The conditions, a is not equal to 0. In case a equal to 0, this linear polynomial becomes a constant because 0 into x equal to 0 means b is a real number. Therefore if a equal to 0, this polynomial equal to constant terms. And examples, 3x plus 15 and 4y minus 11. Right? Here variable is x, in this polynomial variable is y. So both are linear polynomials. And second one is quadratic polynomial. Right? The second one is quadratic polynomial. A polynomial of a degree 2 is called quadratic polynomial. The degree of polynomial equal to 2, such polynomial is called the quadratic polynomial. The general form of quadratic polynomial is ax square plus bx plus c. This is the general form of quadratic polynomial, ax square plus bx plus c. Here a, b and c are real numbers. A, b and c are real numbers and a is not equal to 0. This is the condition. Here also a is not equal to 0. In case here a equal to 0, the quadratic polynomial becomes linear because 0 into x square is 0. Right? 0 into x square is 0. This bx plus c. Therefore, this is a linear polynomial. Therefore, here a is not equal to 0. The examples of quadratic polynomial: 2x square minus x plus 2 and x square plus 17x minus 22. This is the concept of the quadratic polynomial. Next one is cubic polynomial. The third one is the cubic polynomial. A polynomial of a degree 3 is called cubic polynomial. Right? A polynomial of a degree 3 is called, sorry, this is not quadratic, cubic polynomial. A polynomial of a degree 3 is called, this is a cubic polynomial, not quadratic, it is a cubic polynomial. The general form of cubic polynomial is ax cube plus bx square plus cx plus d. Right? General form, this is the general form of cubic polynomial, ax cube plus bx square plus cx plus d. Here a, b, c and d are real numbers. Right? A, b, c, d are real numbers and a is not equal to 0. A, b and c are real numbers or belongs to R and a is not equal to 0. In case a equal to 0, in this case, this cubic polynomial becomes quadratic. Right? Because 0 into x cube is 0. Therefore, bx square plus cx plus d. This is a quadratic polynomial. Therefore, here a is not equal to 0. Yes, some examples are there. 2x cube plus x square minus x plus 2. And another example, minus 3x cube plus 7x square plus 17x minus 22. Right? This is cubic polynomial. Let us consider a polynomial. Right? You take any quadratic polynomial, p of x equal to, or you take h of x equal to, or you take f of x equal to, whatever. Variable is x, therefore you take p of x equal to x square minus 4x plus 3. Right? X square minus 4x plus 3. Substitute x equal to minus 1 in the above polynomial. Right? Substitute x equal to minus 1. Minus 1 square whole square minus 4 into minus 1 minus 4 into minus 1 plus 3. Right? This equal to minus 1 square equal to plus 1 and minus into minus plus 4 plus 3. This equal to p of 1 equal to a. P of 1 equal to a. Here 8 is called the value of the polynomial. Right? Here this value 8 is called the value of the polynomial when x equal to minus 1. Okay? 8 is called the value of the polynomial when x equal to minus 1. So in general, the value of polynomial p of x when x equal to k is any real number, right? When x equal to k is any real number, is the value obtained by substituting x as k. Replace x by k. It is denoted by p of k. It is denoted by p of, means here substitute x equal to k. The given polynomial is p of k. So I substitute x equal to 1 in the above polynomial. Substitute x equal to 1 in the above polynomial. Where x equal to 1 square minus 4 into 1 plus 3. Then simplification. So 1 minus 4 plus 3 equal to 0. Here 0 is called the value of a polynomial. Right? Here 0 is called the value of a polynomial when x equal to 1. When x equal to 1. So in general, the zeros of the polynomial, right? In general, the zeros of the polynomial is defined as any real number, the value of x for which the value of the polynomial becomes 0, right? The polynomial becomes 0. A real number k is a 0 of a polynomial p of x if p of x equal to 0, right? This is the zeros of a polynomial. When the value of polynomials becomes value 0, so that polynomial is called zeros of a polynomial. Next concept is the geometrical meaning of, right? Next concept is geometrical meaning of zeros of a polynomial. Let us consider a linear polynomial 2x plus 3. The linear polynomial is 2x plus 3. You'll take the consider polynomial equal to, you'll take f of x or h of x, or you take y equal to 2x plus 3, right? Y equal to 2x plus 3. Substitute x equal to minus 2, right? Y equal to minus 2. Substitute in this equation. X equal to minus 2. 2 into minus 2. Minus 4 plus 3. Minus 1. Substitute x equal to 2. 2 into 2. 4. 4 plus 3. 7. Right? When x equal to minus 2. Y equal to minus 1. X equal to 2. Y equal to 7. These 2 points. Minus 2 minus 1. 2 7. Right? So mark in the graph. Right? Minus 2. X minus 2. Y minus 1. X, let us get this x minus 2, y minus 2, this point, right? So this point, x minus 2, y minus 1, and another point, x2, y7, x2, y7, this point, 2, 7, this is minus 2, minus 1. This is the straight line, this graph becomes straight line. This line intersects the x-axis at only one point, right? This line intersects at the x-axis only one point, that is minus 3 by 2. This point is the minus 3 by 2. Right? The line intersects the x-axis. The line intersects the x-axis at the point minus 3 by 2 and 0. Minus this point. Minus 3 by 2 and 0. The zeros of the polynomial 2x plus 3 is minus 3 by 2. The zeros of the polynomial 2x plus 3 is minus 3 by 2. And the zeros of a polynomial is the x coordinate of the point where the graph intersects the x-axis. See the sentence. The zeros of the polynomial is the x coordinate of the point where the graph intersects x-axis. This point. Where the graph intersects x-axis. This point is called zeros of a polynomial. Right? This graph is intersect x-axis at the point minus 3 by 2. The minus 3 by 2 is the zeros of the polynomial. And the point, the graph of linear polynomial intersect the x-axis at maximum of one point. Right? The linear polynomial intersect x-axis at the maximum of only one point, or it is does not intersect like this. If graph is like this, this graph is does not intersect x-axis. Maximum of one point. A linear polynomial has a maximum of 1 0. That is the point is minus 3 by 2. Next one is, let us consider the quadratic polynomial x square minus 3x minus 4. Right? So take a table x equal to value and y value, corresponding y value. We'll take x equal to minus 2, the corresponding value is y value is 6. Substitute x equal to minus 2 square, right? 4. So minus 3 into, substitute x equal to minus 2, right? Minus 3 into minus 2 plus 6 and minus 4. We get y equal to 6. Substitute again x equal to minus 1 in this equation, we get y equal to 0. Wait, x equal to minus 1. Minus 1 square 1. Minus into minus. Plus 3. 1 plus 3. 4 minus 4. It is 0. Substitute here x equal to 0. 0, 0 minus 4. Y equal to minus 4. Substitute here x value. We will get the corresponding y value. X equal to 1. Y equal to minus 6. 2 minus 6. All these are points. Next try a graph. Minus 2, 6. My x-axis minus 2, y is 6. This point. And x minus 1, y 0. Right? X is minus 1, y is 0. This point, second point. And x 0, y minus 4. X 0, y minus 4. and mark all the points. We get a curve like a parabola. We get a curve like a parabola. Right? Next, the graph of quadratic polynomial intersect x-axis maximum of 2 points. Just you observe, right, this graph. The graph intersect the x-axis 2 points, right? -1, 0. This point here and here. This graph is intersect or cuts the x-axis. There are 2 points. That is the statement. And the quadratic polynomial has a maximum of 2, 0, right? Either 1 or 2 or no 0. Means the graph intersect x-axis only 1 and 2 times, or not intersect like this. If a line is like this, it does not intersect the x-axis. That is no 0. Next one is the shape of parabola of a quadratic polynomial ax square plus bx plus c. Here a is not equal to 0 depends upon a. This value equal to positive, the parabola opens upward like this. Opens upward, right? If a value is negative, means less than 0. A value is less than 0. The parabola opens downward. If a is positive or greater than 0, the parabola opens upward, and a is less than 0, the parabola opens downward. Next one, consider the cubic polynomial y equal to x cube minus 4x, and substitute x equal to -2, and you get corresponding y value is 0, and x equal to -1, you get the corresponding y equal to 3. Means substitute here x equal to -1. -1 cube -1, so minus of minus it is +4, right? This equal to -1 plus 4, you get the 3, and substitute x equal to 0, y is also 0, 0, 0, you get y is also 0, and draw the graph, right? -2, 0, x-axis, -2, y 0, this point, and x -1, y 3, x -1, y 3, right? This x -1 corresponding y is 3. Next, x0, y 0, x0, y 0, and similar points, and draw a graph. See the graph. This is a cubic polynomial. This graph intersect x-axis 3 times, right? 1. Right? This graph intersect x-axis 1, 2, and 3. Here, here, and here. Right? The cubic polynomial. The graph of cubic polynomial intersect x-axis 3 times. Right? The graph of cubic polynomial intersect the x-axis maximum of 3 times. Therefore, the cubic polynomial has a maximum of 3, 0. It is not quadratic. It is cubic polynomial has a maximum of 3, 0, 1 or 2 or 3 or no 0. So, in general, nth degree polynomial has a maximum of n0. In general, nth degree of polynomial has a maximum of n0. Next, the problem. Look at the graph in the given below. Each is the graph of y equal to or p of x, where p of x is a polynomial. For each of graph, find the number of zeros of a p of x. Right? This graph, see the graph, observe the graph. Right? This graph intersect at x-axis only once. Right? Therefore, the number of zeros is 1 because the graph intersect x-axis only one time. Therefore, the number of zeros is 1 as the graph intersects the x-axis at the only one point. Because the graph intersect at x-axis only one time, therefore number of zero is 1. In second question, see the second graph. Right? The graph intersect x-axis 2 times. Right? The graph intersect x-axis 2 times, here and here. Therefore, the number of zeros is 2. The number of zeros is 2. And see the next graph. Right? The graph intersect x-axis. That's it. The graph intersect x-axis 1, 2, and 3. 3 times. The graph intersect x-axis 3 times. Therefore, the number of zeros is 3. Therefore, the number of zeros is 3. because as the graph intersect x-axis at the 3 points.